All right. Good afternoon to everybody. Um, Also, I have been introduced already, but I didn't really understand what Andrew is saying. So my name is Andreas. I'm the CTO of Rightware. The Rightware is a Finnish company based in Helsinki. Also, I'm from Germany, living near Munich. Just a little bit about me. I've studied electrical engineering and now have 25 years experience in all areas of software development, and also spent quite some time in automotive. Namely, companies I worked for is BMW, Novero, which was Nokia Automotive, Electrobit, now owned by Continental. And now I'm the CTO of Rightware. But no fear, this won't be a sales pitch. We talk about a serious topic here. I will talk to you about the rising complexity in the car HMI development and how to tame it. So yeah, everything, everywhere, all at once. That may be the headline when it comes to these days HMI. But let's start a little different. So my presentation today is split into two parts. Part one, we will do a little time travel going 40 years back and then until today to see how the world of automotive human-machine interfaces have changed. I think it's quite important to understand how we got there where we currently are. In part, and this part will also be a little bit the entertaining part of the presentation. And then in part two, we'll actually dive into how do we solve now this complexity. And I will present 10 specific requirements that a modern HMI toolkit and framework has to fulfill in the market of modern cars. So, but for now, let's do the time travel. Get on the ride. We are going back. We're starting at the 80s. 80s meaning Ronald Reagan has elected the president of the United States. There's the brand new music channel MTV playing Video Killed the Radio Star in endless loop. Almost forgotten in the 80s, Microsoft recently just released a software called Word. And the Time magazine makes the computer the man of the year. And everyone wanted to have a car like Knight Rider's kit. However, if we look in cars in the 80s, they are actually far less spectacular, and the operation is still completely analog. If you remember that time personally or from videos and pictures or YouTube, there are plastic speedometer needles, a few tiny lamps as warning signs in the instrument cluster. When it comes to infotainment and navigation in the 80s, you rely on the passenger's willingness to talk to you or sing along the radio or read a paper map. Anyone who had a cassette deck or was able to open the sunroof actually was lucky. That was extras in a car at that time. And probably the most popular extra of that decade was the cigarette lighter. But of course, time didn't stand still. Once we entered the 90s, East and West Germany was reunited and the European Union was founded. Friends, one of the most popular TV series of all time, hitting the televisions, and electronic toys like Furbies and Tamagotchis are making their way into children's rooms. PCs start becoming connected to this brand new thing called the internet. The information age has begun. But however, if you look at the cars of the 90s, nothing really groundbreaking has happened. The cockpit is still operated with mechanical buttons and levers, rotary controls and sliders. And the biggest news that early adopters are increasingly asking for is maybe an air condition and a CD player. Otherwise, there's not much news in the cockpit. Not yet, because things are going to change, starting with the 2000s. So when New Year's Eve 2000 went by and the big Y2K bug did just not happen, we knew digitalization can no longer be stopped. After 9/11, the turbulent decade is politically marked by the fight against terror. The decade ends in a recession triggered by financial crisis. But also Facebook comes out and makes social media a mass phenomenon. YouTube paves the way how we consume video, and it was the first real major video streaming service. And Apple's iPod changed the way we consume music. And as you see in our cockpit, there's an iPod connected. For the time being, the car still remains a fairly self-contained bubble. Only electronics and software suddenly became a key thing in a car. Mobile phones have seen one of the fastest adoption rates ever. And there was another genius idea you also see on my slides. Somebody thought of converting the cigarette lighter into a 12-volt socket by just renaming it. I think that was a pretty genius idea. The biggest technology innovations in that time in the cockpit, the early 2000s, was the first introduction of serious vehicle assistance. So ESP, ACC, and map services. And actually, these both areas become their own domain in the automotive industry called ADAS, Advanced Driving Assistance Systems, and navigation, which we will see later. The launch of Apple's iPhone and the expansion of the global mobile data networks at the end of the decade, it became clear from now on, we are all connected everywhere at all times to a digital parallel universe that is expanding rapidly. From 2010 onwards, software really ramps up. Software achieved its own status in the vehicle. You see things suddenly like head-up displays and digital clusters replacing the plastic needles in the cockpits. IVI screens are the new normal in the center console. Maybe I need to explain IVI. That's also where that abbreviation first showed up. It's in-vehicle infotainment. You will hear that later a lot. These IVI systems host entertainment services, vehicle settings, navigations, and the new popular rear camera views. The cockpit is equipped with more and more digital services. Data like traffic information is streamed in real time from the cloud. Smartphones are supposed to interact seamlessly with the vehicle. Mirroring personal device interfaces with CarPlay, Apple CarPlay, and Android Auto is an option back then, but by now, today's standards, it has become a must-have functionality. I think 84% of new car buyers in the US buy only a car if it has CarPlay or Android Automotive built in. So it's a major deciding factor here. Also, there are no new interaction controls as touch and voice showing up in these years and replace more and more the analog knobs and levers that we knew from the years before. If we look at today's cars, the cockpits we launch are huge command centers with an app for almost everything, surrounded by an ecosystem of mobile devices and, of course, cloud data. Also, new use cases come suddenly into the car. Globalization and climate change bring these new use cases, and we also have more and more regulations in our industry that also complicate a lot of processes in software development. Electric vehicles are starting to show up, and electric vehicle charge management features show up, but also extensive localization and personalization options you will now find in the car. Hardware-supported functions get now optimized with AI algorithms, and functionality grows with each new hardware generation. The rear cameras we had in the last decade now become 360-degree surround views. ADAS, driver assistance, or autonomous driving, level 1 becomes level 2, level 3, and we know where this is ultimately going to lead. If we now look at tomorrow, I think there was just a couple of weeks, there was the Shanghai Motor Show. And I don't know if anybody of you have watched what was shown there. But suddenly screens, HMIs, user interface became these immersive photorealistic HMIs with screens spanning the entire width of the car. And I think in the following now decade, we will mostly be busy in harmonizing and optimizing this massive amount of shiny functionality and also non-standard technologies. So the integration of screens, ECUs, so electronic control units, and all the data that is collected is key. Cars get connected to the so-called Internet of Things, so you can control the temperature of your house or apartment from the car. All new use cases. Augmented reality is on the rise and brings data visualizations directly in the visual line of the driver with the real world. Also, we think more sustainable and by keeping vehicles updatable by software updates over the air. And that requires building software architectures much more modular than it used to be. So also, the in-car software is a fairly new field. As we've seen, it's just reaching maybe 1 or 2 decades back. It's one of the most complex and responsible areas a software developer can work nowadays. The costs of HMI development and integration have literally exploded. If you paid attention to my slides, in the lower right corner, there was this black graph, HMI complexity, and then the system electronic/software cost. And it basically, since the 80s, has increased complexity exponentially. Just let that sink in. So in the last decade, the automotive industry has made this giant leap in software innovation. So while in beginning of the 2010s, only 10% of the functions in a new car were controlled by software, this will now rise to 50%, so half of the costs in the next few years. So what does it all mean? I found, by looking into it, an interesting comparison. I mean, the source is on the slide here, that compares code bases in lines of code. Also, I'm aware lines of code is maybe not a good KPI, but I found it quite impressive comparing modern car software in a modern vehicle with 100 million lines of code compared to things like Mac OS X, Facebook, Android, or Google Chrome. So in-vehicle software has surpassed the code base of many other areas these days. So the big question is now, what does it mean for the car maker, for the so-called OEM? In a nutshell, we are currently in a situation I would call the automotive HMI triangle. So obviously, everybody knows the world is getting more complex with globalization and digitalizations everywhere. Customers, car buyers, expect that their cars more and more behave like their smartphones. So we have to increase customer expectation. Also, this leads then to an avalanche of new functions and more powerful hardware. And at the end, buzzword alarm, the software-defined car. So let's just take a quick look. I've taken from a real-world application, not saying what car maker it was, but that we worked on in a project here at Rightware. So this is just a visualization of a very typical part of a requirement sheet or statement of work we're seeing these days. All that stuff needs to be integrated into the car's cockpit and the HMI, the user interface. So you have all the obvious main functions like RPM, HVAC systems, safety, controlling ADAS, all these things. voice recognition. Then you have basic information like the speed, fuel, range, all these things, the telltales, so the control indicators. Then we have all the settings, factory mode, media, audio, phone connectivity, Bluetooth, radio, analog radio, digital radio, satellite radio in the US at least. You have a whole range of functions that comes in with electric vehicles, battery, charging, charge settings, the energy flow be shown in a nice way. Of course, the overall vehicle status, four-wheel drive, maybe some vehicle settings, drive modes. In this particular case, authentication via face recognition. And on top of that, and we will get to that later in the slides, there are tons of brand-specific things that need to be integrated. So, and to make things more complex, if you look how the screens have evolved, I mean, we maybe started with a small text screen somewhere in the cockpit to a single small screen in the center stage, getting more irregular shapes, no longer rectangular, going over the whole width of the car, basically ranging to all areas. So the driver has now a digital cluster. It has a head-up display, which is just another type of projection system. Mirrors are replaced with cameras and digital mirrors, also displays. You have ADAS systems that require visualization, like very common these days, showing in real time what all the sensors are seeing in the car. I think Tesla probably was the first doing that. The passenger has infotainment, but also certain car controls. Passenger can control the navigation system and the climate. Rear seat entertainment is games, movies. So what is driving all these trends? As I said before, it's the ever-increasing customer expectations. And before we go to the more engineering side, I like to digress for only a few minutes and talk about the driver and something that we call functional value before we return to the development and engineering side of things. So what is functional value? The unification of purpose, excellent design, and performance-driven implementation. I mean, that's the definition. What does it mean? It means we are currently living in an age where it's not necessarily better. Quantity is easy and quality is not. So functional value in this complex use cases means that features fulfill a customer need and serves a purpose in order to find a way in a human-machine interface. Functional value means that design is not just eye candy, good looking, but also conveys a valuable meaning. User interfaces need to follow ergonomic principles, consider situational context, attention spans, and human processing capabilities. With all these functions, it's very easy to overwhelm drivers and customers. So it's not only about just the pure software, it's also the design needs to be very careful to not be distractive, but really serves a purpose to the driver and limits the information to what's needed at the certain point in time. Because let's remember what HMI stands for. Human-machine interface. So the HMI needs to help the driver to deal with the complexity of the machine, in that case, the car. So that's the short digression. So let's return to the engineering side of things. And what we then realize is, when it comes to HMI development, traditional tools are reaching their limits. So for the second half of the presentation, I like to dive now into the solution space. how can we now handle all this complexity that we have seen has been grown exponentially since the 80s to what we have seen like on Shanghai Motor Show 2 weeks ago. I will now present 10 requirements to an HMI framework or tool chain to tame this complexity. So let's dive in. Number one, modular multi-user workflow for team productivity. If you think of car makers and tier ones, at least the big ones, are huge organizations. Tens of thousands of people are working there. Many departments need to collaborate to realize modern cluster and in-vehicle infotainment systems. We have design, user experience department, hardware engineering, software engineering, test, verification, integration. That means project assets, designs, code, functionalities, and more can or should be able to shared and reused across teams and projects. Designers and developers should be able to work in parallel on different parts of such a huge HMI project. Therefore, a modern, modular, collaborative, multi-user workflow is a must-have. Number two, seamless integration with any automotive operating system or platform. Sounds like obvious, but also there is a certain consolidation ongoing in the industry. These days, I would say for infotainment, Linux or variants of that, like the more complete platform from Google called Android Automotive, seems to take the lead in the infotainment world, especially in Asia, but it's also spreading out to Europe and the US car makers. It seems like Android Automotive is the winner in that area. In the cluster, it's a little different. Here, QNX is still dominating the world due to its unique properties in real-time capabilities. We'll get to the topic of functional safety in a couple of slides. So the number of relevant operating systems in the past years actually has reduced quite a lot, which helps. But at the end of the day, every HMI toolkit needs to seamlessly integrate with all relevant operating systems, full stop, no question asked. It's just a hard requirement. Getting back to Android Automotive, that in particular means to cater to the needs of Android developers, you need native Java and Kotlin support. We need a proper integration with the Android UI thread and the ability to use Android Studio for the development. So basically, as an HMI toolkit, you need to be a good citizen in that world. Next, talking about customer expectations and functional value, which we have heard before. These days, outstanding graphic performance is a must-have. Visuals need to be compelling, as customers are used to from their consumer devices. If you look at modern smartphones, tablets, game consoles, or even televisions, we are flooded with high-quality user interfaces and graphics. So it's simply expected from a car. At the same time, the development cycle in the automotive industry is still much slower than in the consumer electronic world. So let me this example. So if you now, after that seminar, go out and buy a new car, a brand new car, model year 23, you might end up with a hardware powering your cluster IVI system that is 5 years old, because the development cycles are so long. So the moment the customer buys the car, the hardware that you have in your smartphone has moved on a lot. Also, if you look at the different car classes and sizes, of course, there's also a different level, like smaller cars, entry-level, cheaper cars have less screens, have less capable hardware, also to save cost. Therefore, HMI frameworks need to be able to achieve great graphics and performance on pretty much any level of hardware. This also means HMI frameworks and toolkits basically need to be hardware agnostic. What comes to the rescue here, and that's thanks to standard graphics APIs like OpenGL and Vulkan, this is today much easier than a few years back where they're not, where all these standard APIs available. So that is really helping. But great graphics also mean great effort. You see a small video here now, a video loop of a modern 3D navigation map rendering. Imagine you would be a designer, technical artist, software engineer, and you need, for every project, for every car model, you need to start programming this from scratch. That obviously is no option. Modern car HMIs have become immersive experiences that go far beyond simple list and button UIs. So designer and developers need ready-to-go content, asset packages, and templates to get a head start. You don't just want to start from scratch. And content not only means visual content, it extends, of course, to extensions and plugins to boost development time. But leave the developer and the technical artist enough space for individual customizations. So you won't find an HMI architecture or toolkit where you don't have some form of plugin, SDK, or anything like that to handle the special cases. Next. Smooth integration with existing workflows. Also super important, I can tell you from talks to many big car makers and tier ones. As we have seen a couple of slides back, how important collaborative work is across multiple departments. This also imposes a great new challenge within HMI development. Because every corporate function, every department might use their own favorite tool for their tasks. So a 2D designer might use tools like Adobe Photoshop or Figma these days. A 3D designer likes to use tools like Maya or Blender for creating their 3D assets. Software developers, on the other side, like to integrate everything in their build and deployment system, the CI/CD system. And of course, they like to do it in an automated, non-manual fashion. So this means HMI toolchains need to have a solution for all these workflows, at least for the most important ones. So this can be importer plugins, certain exporter capabilities, but also things like headless command line interface, so you can integrate the tool in some automation testing, and automated deployment. As I hinted before, with the operating systems and the cluster, we have something very unique in software development in automotive. Also, it's also in medical devices and stuff like that, in aviation, but also in automotive, especially in the cluster HMI. It is simply a requirement to fulfill functional safety regulations. The ISO 26262 standard is mandatory to follow. Things like the check engine on the ABS control indicators, the so-called telltales, are categorized at ASIL B. Let's just remember the time travel. All these indicators were in the 80s, 90s, were lamps or later LEDs. And maybe you have asked yourself why in older cars, once you turn on the ignition, all these indicator lights are turning all on and then off. It's Very simple. It's functional safety. The electronics, not that much software there, was basically measuring the current if these lamps or LEDs are actually not broken or on. These days, of course, we don't have lamps and LEDs. The cluster is a full digital display. So the system and the software needs to ensure that the state of these control indicators is always 100% correct. Otherwise, you're not fulfilling the regulations. Now one could say functional safety is something that needs to be achieved by the entire system, not only the HMI part. The only HMI part is just the visual part, the tip of the iceberg. This is correct. Hardware, operating system, virtualizations like hypervisors all need to play together to get a proper functional safety ASIL rating. But HMI tools and frameworks need to support the developer by, for example, having the means to define and treat functional safety relevant visual items differently, and also check for correct display at runtime on the target. Or even more strict, have a separate rendering engine running under virtualization, under operating system like QNX, and basically have the rendering and drawing of regular HMI and functional safety HMI completely separated. That means that render engines need to support special graphics APIs like OpenGL SC or Vulkan SC, where SC stands for safety critical. We have already seen that we need to achieve great graphics on any level of hardware. But what does it actually mean, great graphics? Again, thinking back of Shanghai Auto Show and see the videos and what have you shown there. You need to have stunning visual effects. These are becoming more and more standard in cluster and IVI. Especially in Asia, the demands are exceptionally high. So therefore, an HMI tool needs to provide easy access to effects and post-processing, boosting the productivity and saving valuable time for designers and developers. So what are these effects? Things like bloom, shadows, reflections, maybe even physics simulations, fog, all that stuff. A couple of them you see on my screen. You see glow, you see reflections. These are typically called effects or post-processing that you need to make quite easy to use. The so-called physical-based HDR rendering is pretty much standard these days, and it's essential for creating these high-quality graphics. Of course, at the same time, you need to follow production-proven automotive processes. Still, this is not a video game. It is, as I said, with functional value, it is something that is delivering a value and might have safety-critical properties attached to them. Number 9 of the 10, I think, if I counted correctly, not number 7, scalability without limits. As we already talked about, big car makers have multiple brands, product lines, individual cars can have individual feature sets. Not sure if when you the last time tried to configure a new car in one of these very complex car configurator web pages, trying to put together your dream car. It seems like the number of permutations of function is endless. In addition, we more and more see pay-per-use models and marketplaces in the cars. That now means I can, for example, book and pay for the heated seat just for the winter part, because in summer I don't need it, instead of paying that upfront. But this all means complexity in the software development process, because ideally the base system should stay the same and the common assets are shared, but all the variable assets can be exchanged super easy. This imposes a great challenge for HMI development and the tools, They need to be efficient in use of resources, both human and computing. Integrated communication framework, or at least connection to existing communication frameworks. Every human machine interface, user interface needs to communicate in the car in order to come alive and fulfill jobs, obviously. Otherwise, it's just a dead screen. Also, the number of screens we have seen are increasing in the cars. And there are different architectures, system architectures in the cars. For example, you might have systems where each screen has a dedicated control unit, or you have something like domain controllers, like big computers that drive multiple displays in the car. Often functional safety requirements dictate the use of virtualization of different parts of the HMI software, as we also learned in the cluster. In any case, some communication, some network layer you need to connect to. These days, many vehicle communication systems can be found. This is starting from simple, old-style, low-level CAN bus signals up to modern communication frameworks and protocols like some IP, dbus, or DDS. So an ideal HMI framework needs to have the means to abstract away the inherent low-level differences you find in these car models, while enabling the designers and developers to do their work long before the car or even the hardware for the cluster or IVI system is available. So it's not only about communicating to the system, but it's also in these early phases, you have the need of simulating data. Last but not least, reducing coding for increased results. What does now that mean for a software developer? But the thing is, not everyone is a great C++ programmer. And quite frankly, this shouldn't be necessary for most of the HMI-related logic. A lot of the interaction business logic you have in graphical user interfaces can be abstracted by state machines and properties of certain widgets. I think a modern HMI toolchain should enable the user to get 90% of the common interaction defined without the need for explicitly coding in a complex programming language. If coding is required, a simple low-code approach like scripting in simple-to-learn languages like JavaScript or Lua is the way to go. Or we even see no-code approaches like visual coding, things you might know from Simulink, where you basically put together your logic, your algorithm graphically. This all makes HMI development much more usable for a wider group of technical artists and developers. And reducing code also means reducing team sizes, and the teams that you have can accomplish more in less time. And with a fewer amount of software, there's also less risk of bugs. And so we should not forget about that. All right. These were my 10 promised top 10 requirements to a HMI toolchain that we need to develop IVI cluster system in modern cars. Let's just quickly reiterate over them. So we had modular multi-user workflow, the seamless integration with automotive platforms and operating systems, outstanding graphics on any level of hardware, accessible and extensible visualization tools, smooth integration with existing workflows. We talked about the functional safety awareness, the advanced visual effect pipeline, scalability across cars and car models, the integration with communication frameworks, and last but not least, the reduced coding for easier access and for quicker results. So What does it now boil down to? I think what is the main takeaway for today? I think it's quite simple. It is best using an HMI tool set or framework that is purpose built for what matters in the automotive HMI development. I think it's as easy as that. We need to have a tooling that really is addressing the very specific needs in the automotive industry. So, and I promised no sales pitch, so I'm not reading the slide, but at least you have seen the name of the product here on the last slide. But that's it, what I wanted to convey, what I tell today. Thank you much for the attention and hope that was insightful.